Hello again, everybody. Let's take a look at section 9.5. I hope the homework's going well for you. I wrote some notes here at the front end, and notes can, they're there to see and how you're supposed to do stuff. But essentially, this particular section, which is the last section we're going to cover before our test, is showing us a different kind of differential equation to solve. And they typically look like the following: y prime plus some sort of function of x times y is equal to some other, perhaps, function of x on the right-hand side. These are non-separable differential equations, and in fact, in the notes here, I'm saying, here, take this, consider this example here. Try as you may, you can't separate it. You're not going to be able to write it in what form? The form we like for, this is for separable, which is a previous section, would look like g of y dy is equal to f of x dx. This problem I circled over here, you can't get in that form. But we can solve it with our last topic before the test, which is using what they call the integrating factor to take care of business, okay? And the notes are here, and that's for you to kind of understand what's going on. But I want to explain it in a different way. The usual way I introduce this is I go, I've got like y prime plus, I'm going to pretend it's 2x times y. And over here could be something else. And in fact, I'll make something up. I think I did. Something like x e to the minus x squared. Remember, the goal is I want y of x equals. I want the function itself that fits this differential equation, okay? So if I were to take this function and figure out his y prime, and if I were to plug it in there, and if I took the y and I plugged it in here, the two sides would agree with each other. A bunch of x's, whatever happens, happens, and they would match. Okay, so I'm looking for that function that does that. It has to satisfy this strange differential equation. Okay. Someone came up with a nifty little trick. Rewrite it. We're going to follow the bouncing ball on this one. And the story is, I'll jump over to the side here and say, just remind you so that this is no huge surprise, take this function and derive it. Let's say e to the x squared. What do you get? When you derive that guy, what do you get? Well, it's a chain rule, isn't it? Chain. Okay. So we get e to the x squared, right? Times the derivative of x squared, which is 2x. This clever person was bored, it was raining, and we were all quarantined, and he had nothing better to do, ha. So what about if we took this function, e to the x squared times y, and derive that implicitly with respect to x? Well, the product rule would say derive the first function, which we already have. It's e to the x squared times 2x, and then leave y alone, right? Plus, and leave him alone, e to the x squared, and hit him with the derivative of y, which I'm going to call y prime. Okay? All right. So here's the thing. This thing that we derived and came up with right here, this guy, is almost the same as the problem that I invented. So what we have is the 2xy right there, and we have the y prime. And what's missing is this guy. If I had the whole thing, I would say it's the derivative of e to the x squared times y. So what? So remember what we're trying to do is we're trying to lift ourselves up from the derivative or rate of change level and bring us up to the actual original function level. So I need to somehow get rid of this y prime. It's making me crazy. I need to get up to the original function level. Well, if I can turn the left-hand side into the derivative of something, okay, right there, then I'm off to the races with this problem, because I could say, hey man, that's the derivative of this. And when I antiderive it, the derivative and antiderivative will cancel. In other words, I'm going to create something on the left-hand side over here that is a derivative, so that when I integrate it, a derivative of a known function, so that when I integrate it, I get to that function. And this is the essence of what they call the integrating factor. So what I'm going to do is I'm going to sweep in with an e to the x squared, and this is all contrived, you understand. This is all made up stuff. And you see, you may not know what y is yet, but by introducing the so-called integrating factor, and we'll see a couple of examples before we're done on this video, it works. So we end up, and remember this step, remember this is the one that confuses students, going from here to writing it as, hey man, I'm looking at the derivative with respect to x of e to the x squared times y. They go, well, where did everything go? And I go, all of that is this, and we did the work over here, you can see that. That is the derivative of e to the x squared times y. On the right-hand side, whatever happens, happens. Looks like I made it so that the e to the x squareds cancel, and you just get an x. So what? So here's the beauty of it. You can integrate both sides. Like I said, antiderive a derivative, and you're back to the original function, e to the x squared times y. And on the other side, whatever happens, happens. In this case, you get 1/2 x squared. How important do you think it is to put the plus c in there? Extremely important to do that. Okay? So, last step is, now we can solve for y by dividing through by e to the x squared, and e to the x squared. And however you want to write it is up to you. You might say something like, well, what I'm looking at is 1/2 x squared plus some constant that I don't know, all over e to the x squared, and we would be done with the problem. Remember, the goal is to find that function. Okay, so that was a contrived story, and what I put in there was a lot. This is a confusing section. So this next one, I'm just going to go step by step on it, okay? And just follow the bouncing ball without explanation. But it really boils down to making the left, you want to basically make this note, make the left side the derivative of a product. And the weird thing that happened is, way over here when we did the chain rule of this guy, and I was seeing that 2x, I saw that 2x. We're going to go backwards. Instead of deriving, we're going to take this 2x, integrate it to find the x squared, and that's the power of e to use. E is spectacular for this because when you derive it, you get e again. So putting that integrating factor in really does the trick. Okay, let's look at this one together. Okay, here we go. Best to look at an example. You're absolutely right. Here's the first thing you want to do. Number one, get it in y prime plus f, what is it? F of x, y equals g of x form first. That means if you don't have y prime, which we don't, we're going to have to divide. So I'll write it out. 2x y prime plus y is 2 square root of x. And we are going to divide by the 2x to get y prime by itself. I'm going to give you one to do after this, so pay very special attention. So we got y prime plus, I'll write it as 1 over 2x times y. You'll see in a moment y. And this one reduces down to, it looks like it's 1 over square root of x. Okay. It's time for the integrating factor. So that means I'm going to make some space and multiply all the way across with it. With what? With what is a good question. With this, here's the integrating factor, how you find it. Now, the book says it's I of x. You can ignore that, whatever. It's equal to e. Now, here's the thing. Back up, Weber, I am. See this guy here? That's the derivative of the power of e. That's the derivative of the power of e. Remember, when you derive it, it's going to be e to something, e to something. This is the chain rule. I derive it, I leave it alone, and then I derive the power to get, and this is the derivative of the power. The derivative of the power of e, and e to the whatever. We have to find it. That's the integrating factor. So it's going to be the integral of 1 over 2x dx. Believe it or not, we have to antiderive it to find the power of x to use. Because by the chain rule, 1 over 2x is the power's derivative. Okay. All right, I know it's confusing. E to the 1/2 integral 1 over x dx is e to the 1/2 ln of x, right? Pretend x is positive for now. That's it. But that's not all. Look, really, seriously, bring that guy in as a power. E, this doesn't always happen, but on a lot of your homework problems, you're going to want to do that. What happens to the ln and the e? They cancel. They're inverse functions. And you get really, that's your integrating factor, believe it or not. It's not any power of e anymore at all. I mean, the power of e up here that I would put is e to the 1/2 ln x. 1/2 ln x. Why am I bothering to write that? I usually don't, because I have a simpler guy. Let's do the problem over again. Y prime times plus something else times 1 over 2x times y is equal to the same thing, because you multiply across the entire equation, times 1 over radical x. And now we know the integrating factor is just the square root of x, square root of x, square root of x. Believe it or not. Okay, so what we have is the square root of x times y prime. Look at how this one cancels. It's 1 over 2 radical x. I don't know if that rings a bell with you or not. When was the last time you derived the square root function? Derivative of the square root function is 1 over 2 radical x. And on the other side, we have 1, just 1. That's it. Okay. Believe it or not, we did it. On the left-hand side is the derivative with respect to x of the square root function times y equals 1. I'll let you just stare at that, pause it, and look at that. That's important. Right there is the important move here. Okay, if you can convince yourself that this is making sense, then you are well on your way. Now, you may not be there yet, but if you just stare at it. Okay, so the last step, if you do that, you're in good shape. You just integrate both sides and cancel the derivative, and you get the square root of x times y is equal to x, and don't forget the plus c. Okay, last move, y is equal to x over square root of x plus c over square root of x. So why don't we just say that y is equal to the square root of x plus some unknown constant over the square root of x. And until you give me an initial condition, which is going to be the next video, that's our answer. We found it. We went from all the way up here, find y. Okay, that thing was kind of slow. I can't do it. Oh well. Oh no, I lost my pen. There we go. Uh-oh. It's always something for some reason. No. Okay, good. We went from this equation, y prime and y, trying to find y, and all the way down here we found the function that works. Now what I haven't done is plug that in to see if it checks out, but what I want you to do instead of doing that is try number 11 in your homework, and it looks like this. So take a pause. I'm pausing, and then you pause the video and try to do it yourself, okay? Okay, welcome back. Let's see if you got what I got. We're going to take this equation, x y prime minus 2y is x squared. I hope you took a long time and really tried seriously to do that problem. You're going to get rid of the x. You know what drives me crazy is up here I go, step 1, get it in that form first. If you want to do this, step 2 is find the integrating factor. Step 3 is multiply through with integrating factor. Step 4 is write left side as product rule. Okay, derivative of a product, let's say. Okay. And you know what it always is? It's always the integrating factor times y, every time. And then integrates, what was that, step 4 somehow? Step 5, integrate. 6, solve for y. And there is a 7, find c. And it doesn't have to be, you need, I'll say need initial condition. And that's going to be next video. And it's easy, it really is. And that doesn't have to be 7, it can be whenever you're done integrating. Okay, so back to this one then, step 1, we did that. All right, let's keep going. So we have y prime minus 2 over xy is x. Okay, integrating factor, here we come. This guy, even the minus sign, all of it, you take e, you integrate all of that, minus 2 over x dx. Well, that's equal to e to the minus 2 integral 1 over x dx. Did you figure that out? And in this case, we've got e to the minus 2 natural log of x. And if you followed what we did, this is what we did next. We went e to the natural log of x to the minus 2. And you cancel that, and your answer, your integrating factor is 1 over x squared. Okay, so we're going to multiply through with 1 over x squared with y prime. I'll do it this way. Minus 2 over x times this guy times y, and equals x times this guy again. And it is 1 over x squared. We're supposed to now stare at this side. Well, no, not yet. You have to clean up that stuff so you can see it better. So what I've got is, I'll write it as powers. I'll write this as x to the minus 2 times y prime. Here we have a minus 2x to the minus 3 times y. And on the other side, we have 1 over x. Look at that. Did you know that that's a product rule? See it? What's the derivative of x to the negative 2? Minus 2x to the negative 3. Beautiful. What's the derivative of y? It's y prime. That's a product rule. This is like f g prime plus f prime g. Product rule. So we state that it's the derivative of a product. Which functions? Well, the functions are your integrating factor, which is x to the minus 2 times y. And on the other side is 1 over x. Okay. We now integrate both sides. I know it's tricky. It's probably very involved. You got that canceling. You've got x to the negative 2y is the natural log absolute of x plus c. I think the absolute is necessary. And since this is really 1 over x squared, y is equal ln of absolute x plus c. Depends on if x is positive or negative, if we need the absolute value. But here's your answer. Y is equal to, I would say, x squared parentheses natural log absolute x plus c. Now the thing is, we haven't proven that's a solution, but that's where we're going with it. And that's all she wrote, folks. Let's see if I can do this one right. We're going to stop recording.